What's up guys? Welcome to Calculus Club. In this video, we are going to be talking about the properties of limits, okay? These are the properties of limits. You see them on the screen in front of you. All of these properties of limits are pretty straightforward. They're exactly what you think they would be, okay? We'll just go over them quickly and give you a couple example problems to practice, okay? So let's get into it. All right, so the first property of limit is called the scalar multiple property, okay? And all this really says is that if you have some constant times your f of x, you can simply bring that constant out front, okay? So they write it with the b, the f of x. Not much happening here. You can just bring the constant out front and only evaluate the limit as x approaches a of f of x times b, okay? That's the scalar multiple property. The sum or difference property just says that I can essentially evaluate each of these independently. So instead of taking x approaches a of all of this, I take the limit as x approaches a of x squared plus the limit as x approaches a of cosine x, and this also works with a minus, okay? So again, exactly how you think you would handle this problem. Nothing difficult here. The next is the product property. Same thing. I can just multiply, I can distribute this limit and I can multiply the two together, okay? Again, super easy, straightforward. And then two more, the quotient property. So in the quotient property, I can essentially distribute this limit x approaches a to the top and the limit x approaches a to the bottom. And so I can take those limits individually and then compute the ratio, all right? And the last one is the power property, and that just pretty much says I can bring this n outside and I can evaluate this limit raised to the n. Okay, so those are all the properties of limits. Now let's have a go at some example problems, okay? So go ahead and pause the video and try this problem. All right, so I hope you paused this video and you tried all of these on your own. All right, so let's go ahead and do them together. So for part A, of course, I can just distribute this. All right, so then I'm going to get the limit as x approaches negative 2 of f of x plus the limit as x approaches negative 2 of 5g of x, but we know we can bring that 5 out front. So let's go ahead and do that. Let's bring the 5 out front and we'll put the g of x here. So when we plug these in, let's see, negative 1, negative 2. So the pink is the f. So the limit as x approaches 2 of negative, limit as x approaches negative 2 of f of x is just going to be 1, right? This is f of negative 2 is 2, but the limit, the left and right are both heading towards 1. So we get 1 plus 5 times the limit as x approaches negative 2 of g of x. Well, they both approach negative 1. So negative 1, add those together, 1 plus a negative 5 is going to give us a negative 4 for a. All right, hope you got that one right. So for part B, let's change color. Everything is more clear. So the limit as x approaches 1 of f of x, g of x. Again, we can distribute these. All right, so we're going to get the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x, all right? As we approach 1, the f of x, we are approaching to 2, so this is going to be 2 times the limit as x approaches 1 of g of x. Well, the left approach is approaching negative 2, and the right approach is actually approaching negative 1. So these two, the left and the right approach, do not agree. Therefore, this limit does not exist. Therefore, the part B, this does not exist, okay? I don't think I can really put equals does not exist, but this does not exist, okay? Maybe I should just write it like that. Okay, for this one, we got negative 4. And now let's take a look at the last one. So I don't have much room here, so let me go ahead and just erase this to compute part C. So when I compute part C, I'm going to do the limit. So I distribute, of course, the limit to the top and bottom. So the limit as x approaches 2 of f of x divided by the limit as x approaches 2 of g of x. Okay, so let's plug these in. Here's my 2. The limit as x approaches 2 of g of x is this blue. So it looks like the limit as x approaches 2 of g of x is 0. That's already not looking good. We have a 0 in the denominator. The limit as x approaches 2 of f of x, well, that one's fine. As x approaches 2, that looks to be about 1.5. But we have a 0 in the denominator, okay? So this one also does not exist, okay? And there isn't any additional work you can do here because the denominator does not exist, and there's no way of manipulating this to make, not a 0 in the denominator. It's just that one does not exist. Okay? Yeah, so those are those, and I have a couple more very important ones. All right, so now I want you to think about this trigonometric limit. This is a very important trigonometric limit. So I will not tell you to memorize very many things in calculus. I won't recommend you memorize many things. This you definitely want to memorize because it will come up over and over throughout the calculus course, okay? Now, instead of just giving you this answer, I want you to explore it on your own, okay? So take out a calculator, go to Desmos.com, all right? And I want you to graph this, take a look at the table, and determine what is this limit, right? If we try to just plug in 0, what happens? We get sine of 0 over 0, which is, well, sine of 0, that's the y value, well, it's 0 over 0, right? 0 in the numerator is not a problem. The problem is the 0 in the denominator. Okay, we cannot have a 0 in the denominator. It is what we call an indeterminate form. All right, 0 over 0 is an indeterminate form. Okay, we'll talk more about that in later videos. But yeah, I want you to explore this on your own. Graph it, use the table. What does this limit equal to? All right, so I hope you took a second to graph it, to look at the table, and I hope you realize that this limit is going to be 1. Okay, we can see both the left and the right are both heading towards 1. Yes, there's a discontinuity at 0 because the denominator is 0. That's always a discontinuity. But as we approach 0, both the left and the right are both approaching 1. So the limit as x approaches 0 of sine x over x equals to 1. And this is super important, okay? I recommend making a note card on it. Limit as x approaches 0, sine x over x on one side, 1 on the other. You definitely want to memorize this, all right? Now with this knowledge, I want to give you another limit, okay? Another very important limit, and that is the limit as x approaches 0 of 1 minus cosine x over x, okay? Now you are going to use this knowledge that we just found with the limit as x approaches 0 of sine x over x equals 1. You're going to need that to solve this. Now this one's a little tricky. I highly recommend you try it. You struggle with it, okay? And I'll give you some clues here. I'll give you 2 hints. One, in order to solve this, you're going to need to multiply the top and the bottom by 1 plus cosine x. And then you also need to remember that the sine squared of x plus cosine squared of x equals to 1. Okay? So using those 2 bits of knowledge and the limit rules that I just gave you, see if you can find the limit as x approaches 0 of this function. Okay? And you cannot just plug in 0. Let me just remind you, you cannot just plug in 0 because if I plug in 0, I get a 0 in the denominator. Mathematical error message. All right, so try this, pause the video, and try to solve this one. All right, so I hope you paused the video and you tried this one. Let me show you how to do it, okay? So we have limit as x approaches 0 of 1 minus cosine x over x. And I already gave you the first clue. That is to rationalize the numerator, which you've also done in previous video. Okay, so we're going to multiply by 1 plus cosine x over 1 plus cosine x. Remember, we can do this because we're essentially just multiplying by 1. So we're not changing any of the values of the function, or any of the y values of the function, okay? So when I multiply this together, what happens? Remember, I need to distribute. So I'm going to multiply the 1 by 1 and by cosine x. So I'm going to get 1 plus cosine x. And then I need to multiply the negative cosine x by 1 and cosine x. So I'm going to get minus cosine x minus cosine squared x. All right. And all of this, I'm just going to leave it like this. You'll see why in a second. X times 1 plus cosine x. Okay, and now some things are going to cross out, which will make our life a little bit easier. The cosine x and the negative cosine x cross out. So we're left with 1 minus cosine squared x on the top. Okay, so we're at 1 minus cosine squared x on the top. All right, and the bottom we have x times 1 plus cosine x. So far we're at the limit as x approaches 0. Limit as x approaches 0 of all of this equals the limit as x approaches 0 of all of that. All right. Now we're going to use that second hint, the fact that sine squared x plus cosine squared x equals to 1. All right. So if I bring that cosine squared x over to the right, I'm going to have 1 minus cosine squared x equals sine squared x. So I'm going to replace the numerator with sine squared x, okay? Let me change colors here. So this is going to become, all right, the limit as x approaches 0 of sine squared x over x times 1 plus cosine x. And here is where you're going to have another little trick, all right? Instead of sine squared x, I'm going to rewrite this as sine x times sine x. Okay, so I rewrite this as sine x times sine x, okay? And then I'm going to use some rules of limits, properties of limits like I just taught you, and I'm going to rewrite this like this. The limit as x approaches 0 of, okay, so I'm going to do sine x over x times the limit as x approaches 0 of the rest, sine x over 1 plus cosine x. Now remember, we just found the limit as x approaches 0 of sine x over x. What was that? It was 1, right? So this equals to 1 times, well, now we can just plug in the limit as x approaches 0. So we get sine of 0, the sine of 0 is 0, over 1 plus, well, the cosine of 0 is, that's 1, correct? So we're left with 1 times, now 0 over 2, we can have a 0 in the numerator, no problem. We're going to get 1 times 0, and that equals to 0. Okay, so we found our answer. The limit as x approaches 0 of 1 minus cosine x over x equals to 0. All right, and that's another pretty important trigonometric limit. All right, it will come up again in calculus when we start finding the derivatives of trigonometric functions. So also you might consider memorizing that as well, but the most important thing is that you memorize the limit as x approaches 0 of sine x over x. And you could possibly use that to find the limit as x approaches 0, 1 minus cosine x over x. All right? So yeah, so these are all the properties of limits. You have them there. Again, straightforward. They're solved exactly how you think they would be solved. Okay, great. Well, thank you for watching this video, and I hope it was helpful on your calculus journey. And be sure to tune in to the next one. All right, have a great day. Bye-bye.